In this video, we're going to cover functions in Python, but we're going to cover a special type of function in Python. That function is called a recursive function. And one of the most popular uses of a recursive function, or one of the most widely used examples, is the Fibonacci sequence. So if you're not familiar with the Fibonacci sequence, you basically start with two numbers, and the first number is 0 and the second number is 1, and then the next number in that line is equal to the previous two numbers added together. So we can see 1 and 0 added together would give us 1. And now if we go and try and calculate the next number, we look at the two previous numbers, so we can see 1 and 1, so 1 and 1 is 2. And if we try and calculate the next number, we can see that 2 and 1, the last two numbers, is equal to 3, and so on and so on. If we look at these two numbers here, we can see 3 and 2 is equivalent to 5, and so on and so on. So I'm just going to comment that out, and I'm going to leave that there for you guys to take a look at. And the first thing we need to do is we need to define our function. So we do this by saying def, and I'm going to call my function FIB, short for Fibonacci. And now we need to take in a number. So when we go and call our function fib, we're going to pass in a number. So let's say, for example, if we passed in the number 3 and we went 1, 2, 3, we should get the number 1 being displayed out to us. And if we were to put in the number 4, we would get the number 2. If we were to put in the number 6, we should get the number 5, and so on and so on. So this is going to take a number. So we could call it number, or I'm just going to call it n. And after we get this number, we're going to put a colon at the end of our function like always. We need to go and do some checks. So the first thing we need to do is we need to check to see if the number that the user has given us is less than or equal to 0. Because if they give us an input that is 0 or less than 0, it's not going to make much sense. This formula for the Fibonacci sequence is not going to work. It's going to be pointless. So we want to go and tell the user that. So we want to first of all check and then tell them. So we'll say if n is less than or equal to 0, then we put in our colon. We want to print out something like wrong input. So after we've checked to make sure that n is not 0 or a minus figure, we want to go and do an additional check. So to do this, we'll use an else if, and we want to check to see if n is 1. And if n is 1, meaning that this here is going to be our answer, we want to go and return 0. So this would be 1 for the Fibonacci sequence, this would be 2, this would be 3. So to do this, we put in our colon, and we just want to return the number 0. And that's kind of it. It's pretty simple for the input if it's 1. And then we want to do another check to see if it's equal to 2. Because if it's equal to 2, we want to return 1. So again, we're going to have another else if, and we're going to check to see if n is 2. And if it is, we want to go and return the number 1. And if it's not 1 or 2, we're not going to return 0 or 1. We're going to do something else. So we're going to use the else statement followed by a colon, and then we're going to return something a little bit more complicated. So we're going to return fib, which is our function here, but we're not going to pass in n because that's what the original user has placed in. So we're not going to say n, but we're going to say n minus 1. And we're going to say n minus 1 plus fib, which again is the function. And we're going to use n minus 2. And what's happening here is within this fib function, we go down through these statements and we check for, it being less than 0, and we check for it being 1 and check for it being 2. And then if none of these cases are met, we actually go and call this function again. So we start off in our main function by calling this fib function. We come down through these statements, then we get to here and we call this function again, but we're not passing in n, the original number that the user gave us. We're passing in that number that the user gave us minus 1, right, plus fib of n minus 2. Because if we were passing in n every time, this would just be an infinite function. It would never end. The function would just keep calling itself and calling itself and calling itself and calling itself. It would never end. That's why we return the fib of n minus 1 plus the fib of n minus 2. So now that we've got our function created, we want to go and call our function. So we'll say fib and then some number. So we'll place in the number 3 and we can run this, but we're not going to actually see any results because whatever we're returning, like in our previous video, we have to go and wrap this in a print statement to go and actually see what result is getting returned. So when we call this function fib and we place in a number without the print, it is executing, it is going through the normal steps, but we can't see it. So that's why we have to put this print in here. So when we go and run this, we can see that we get 1 as our output. And if we look back up here to our examples and we look at what the output should be for fib of 3, we count 1, 2, 3, and it is indeed 1. If we were to go and use 6 instead, we count 1, 2, 3, 4, 5, 6. So we're expecting 5. So if we run this, we can see 5. If we put in 7 here, we're expecting 8. We see 8. And then we just want to make sure that we check, some edge cases. So we check to see what if it's 1, well, then we get 0. And if it's 2, we should also get 1, the same as 3. And what if we were to put in like something like minus 2 or something, right? Then we get wrong input, none here. So that's perfect. This is how we can use our recursive function in Python.